Lesson 10-6, solving equations by factoring. And in this lesson, you learn to use the zero product property to solve equations. And why is it important? Because you can use equations to solve problems involving diving, history, and bridges. Let's take a look at this real-world application in landmarks. In Acapulco, Mexico, divers leap from Quebrada, okay, the break in the rocks, in literal translation, diving headfirst into the Pacific Ocean, okay, 87 feet below, because the base rocks extend out 21 feet from the starting point. Okay, the divers must jump outward 27 feet. The equation h equals 87 plus 80 minus 16t squared describes the height in feet of a diver t seconds after leaping. Okay, so if you notice, it forms a very the diver forms what we call a parabola, and a parabola is formed by a quadratic equation, and this is the quadratic equation that it forms. H equals 87 plus 80 minus 16t squared. So to find the time at which the diver reaches the highest point of the dive, we can find the time at which he will be 87 feet above the ocean on his way, okay, on his way down. So the diver springs upward at the beginning of the dive and will be at the highest point halfway between this time and the start of the time. Oh, sorry, the start of the dive. So this is what we're looking for, that H right over there. It's halfway point between the start of the dive and uh, the beginning of the dive, and then the end of the dive, or the diver springs up at the beginning of the dive and will be at the highest point at halfway between this time and then the start of the dive. Okay, so from there, okay, we get our equation, which is 87 equals 87 plus 80 minus 16t squared, because that is our h right there. Okay, 87 feet. Okay, and from there we subtract 87 to both sides, so we end up with 80 minus 16t squared, and then we factor out 80 because it's our GCF, end up with 1 minus t squared. So 1 minus 2t, I'm sorry. Okay, and to solve this equation, you need to find the values of t that make the product of 8t times the quantity 1 minus 2t equal to 0. So consider the following products. So if we multiply 8 times 0, we end up with 0 before we answer this question. Okay, and if we multiply 0 times negative 17 times 0, we still end up with 0. And if we have 29 minus 11 times 0, we still end up with 0. And then 0 times quantity 2a minus 3, we still end up with the product of 0. So notice that in each case, at least one of the factors is 0. So this is 0, that is 0, then that is 0, and that is 0. So one of the factors is 0, which brings us to the zero product property, which simply states that this. In the zero product property, for all numbers a and b, okay, if ab is equal to 0, then at least a is 0 or b is equal to 0, or both of them, a and b, are equal to 0. Okay, so thus in an equation that can be written in the form of ab equals 0, in the zero product property can be applied to solve that equation. Okay, so use this information to solve the equation about the diver. 0 equals 8t times 1 minus 2t. So if this is our zero product property right there, then we can basically say that our a is 8t and our b is 1 minus 2t. So this brings us to two scenarios, whether 8t is equal to 0 or 1 minus t is equal to 0 because of that. So if we solve 8 is equal to 0, divide both sides by 8, we end up with t equals 0. If we solve 1 minus 2t equals 0, then this is a two-step equation. Subtract 1 to both sides, okay? And then we multiply both sides by, or we divide both sides by negative 2, end up with 1/2 equals t. Or, let's do what the book did. Okay, we added 2t to both sides and divided both sides by 2, or multiplied both sides by 1/2. Okay, so in this case, a diver will be 87 feet above the ocean at the start of the dive when t is equal to 0, and 1/2 second later. He will be at the highest point of the dive 1/4 second after starting the dive. Okay, so this is how we find that value, and we will solve more problems about this type, and we go to example number 5. Okay, let's take a look at example number 1 first. Example number 1, solve each equation, then check the solution. Again, the zero product property. Using the zero product property, we can solve p minus quantity p minus a times the quantity 2p plus 7, because using the zero product property, we can say that if we can say that p minus 8 is equal to 0, or 2p plus 7 is equal to 0. So we do that. P minus 8 is equal to 0, end up with p equals 8. 2p plus 7 is equal to 0, we end up with p equals negative 7/2. And if we want to check our answer, for that, we use the value for 8, and we find out that it's correct. And we use the value of negative 7/2, and we find out that that is also correct. Okay, and that's how you solve that using the zero product property. Let's take a look at example 1b, using what we know about factoring. So 2t squared minus 9t. Okay, write the equation in the form of ab equals 0. That means we need to equate to 0. Subtract 9t to both sides. We end up with t squared minus 9t equals 0. And using the greatest monomial factor, or the greatest common factor, we factor out t, and that is now t times t minus 9 equals 0. Okay, and from there we use a zero product property. That means t is equal to 0, or t minus 9 is equal to 0. So you end up with t equals 9 and 0. And if we check both of them, we find out that both answers will check out. So the answer is 0 and 9. Okay, for the values of t. So in example 1b, okay, you may be tempted to divide each side by the equation by t. If you did, the solution would be 9, since it is not possible for an equation to have two different solutions. Which process is correct? Okay, so basically what it's saying is this. If you have this particular example right here, t squared equals 9t, you may be tempted to divide both sides by t. And if you divide both sides by t, end up with t equals 9. That's what it's saying. Okay, recall that the division by 0 is undefined, but when you divide each side by t, it is unknown. Right there. So when you're dividing both sides by a variable, you don't know the value of t. Thus, you may be actually dividing by 0. So in fact, 0 is one of the solutions of this equation. To avoid situations like this, keep in mind that you cannot divide each side of an equation by an expression containing a variable unless you know that the value of the expression is not 0. So basically what it's saying is that you cannot do this simply because you don't know the value of t. The only time you can do this is when you know that the value of t is not equal to 0. Okay? So this explains why you need to go through the zero product property. Let's take a look at example 2. Solve m squared plus 144 equals 24m. Then check your solution. We go back to the basics. We equate it to 0. So we equate everything to 0, subtract 24m to both sides. So we end up with m squared minus 24m plus 144. And then look at it carefully. Our factoring methods is the first check for GCF, or greatest monomial factor. In this case, there is none, so we go to difference of squares. These are three terms, so there are no difference of squares. But is it a perfect square trinomial? Is the first term a square? Yes. Is the last term a square? Yes. Is the middle term twice a and b? So our a is m and our b is 12, and the answer is also yes. So this is a perfect square trinomial. Okay, so m minus 12 squared will be the factored form, and the quantity m minus 12 squared is the same as n minus 12 times m minus 12, so equate them both to 0. We end up with both answers being 12. Okay, so if we check our answer, it does makes sense. So the solution is 12. Okay? Let's take a look at example number 3. Example number 3, if an object is launched from the ground level, it reaches a maximum height in the air at the time halfway between the launch and the impact times. Okay, so its height above the ground after t seconds is given by the formula h is equal to vt minus 16t squared. So in this formula, h represents the height of the object in feet, and v represents the object's initial upward velocity in feet per second. Okay, so a flare is launched from the life raft with an initial upward velocity of 144 feet per second. How long will the flare stay aloft? Okay, what will be the maximum height attained by the flare? Aloft means how long will it be in the air? Okay, so what will be the maximum height attained by the flare? So let's explore what we know. The initial upward velocity is 144 feet per second. You need to determine the length of time the flare will be in the air and how high the flare will go. So we plan this by the flare will be in the air until the height is 0. Okay, so the height will be 0. When the height is 0, the flare will be on the ground. So we use the general formula h equals vt minus 16t squared to determine how long the flare will be in the air. Okay, so the flare will reach its maximum height halfway between the launch and impact times. So use the formula again to determine the height at the middle of its flight. So how do we solve this? Okay, so we have the formula h equals vt equals 16t squared, and since the flare will be in the air until the height is 0, which is the ground or the ocean, whatever, so 0 equals 144t minus 16t because the velocity is 144t. Okay, we simply replace that. So we end up with 0 equals 16 times 16t times the quantity 9 minus t, factoring out 16. Okay, and using the zero product property, okay, we now have 16t equals 0 and 9 minus t equals 0. Solve for t. Now have t equals 0 and t equals 9. Okay, so what it's saying is, okay, since 0 seconds is the launch time and the landing time is 9 seconds, the flare will be aloft for 9 seconds. It will reach its maximum height halfway through its flight at 1/2 of 9 or 4.5 seconds. Okay, so using that information, okay, right here first, h equals 144 t minus 16t squared, and substituting time with 4.5. Okay, we now have 648 minus 324, and the height is 324. So the flare will reach its maximum height of 324 feet after 4.5 seconds. And to see if our answer makes sense or not, okay, we simply substitute the value of, okay, 9 to t to be obtained 0, and we find out that the equation or the sentence will be true. So the flare will be aloft for 9 seconds, and the maximum height will be reached after 4.5 seconds. Okay, and let's finish this up with the last example. Let's go back to the beginning of the lesson. What is the diver's maximum height? And when will the diver enter the water? Okay, so the diver will reach the maximum height after a quarter of a second. Okay, so we use the formula h equals 87 plus 8t minus 16t squared, and substitute 1/4 to t. We'll end up with h equals 87 plus 8 times 1/4 minus 16 times 1/4 squared will give us a value of 88. So the diver's maximum height will be 88 feet. Okay? And letter B, when the diver reaches 88 feet, this upward motion has stopped and the diver begins to fall to the sea below. His velocity at this time will be 0. Okay? Therefore, the VT term in general formula would be h equals Vt minus 16t squared is also 0. So that means, okay, 88 equals 16t because our Vt will be equal to 0 because the time is 0. So V times 0 will always be 0. Then we simply solve for t here, and then we divide both sides by 16. We end up with t squared equals 5.5. Okay, and we get the square root of 5.5, okay, because that's how you undo the square of t, and that is approximately 2.35. So it takes the diver 1/4 or 2.25 of a second to reach its maximum height, and about another 2.35 seconds to reach the water. The diver will reach the water about 2.5 plus 2.35 or 2.6 seconds after he starts his dive. Okay, and that is how we use the zero product property in these cases. And the secret word for this particular lesson is guitar. Secret word is guitar. Thank you for watching.